Monosaccharides have hydroxyl and carboxyl group that can react together and form hemiacetal. So hydroxyl and carboxyl group react together. Too loud. Too loud. Monosaccharides have hydroxyl and carbonyl group. Hydroxyl and carbonyl. So hydroxyl and carbonyl. How to remember hydroxyl and carbonyl. Hydroxyl is alcohol. Carboxyl is carbon plus oxygen. So hydroxyl and carbonyl group forms hemiacetal. Intramolecular. Phrenos and Pranos. Phrenos 4加1 5 Pyrenos 5加1 6 Semiacetal formation most commonly involves hydroxyl on the penultimate carbon. What is a penultimate? The second to last carbon. Penultimate. Facial projections are not convenient for cyclic compounds, so Haworth projection is used. Okay. Mechanism in acid, in base. Okay. So what we have is this, and we react to HB, and that attacks H, and that retract, and then it becomes this, because this is a very good electrophile, it will attack there. And this one will go back. And then we will have something like OH, H. And then because we have B minus, that gets there. Where did this O plus come from? Because it how did this class come from? I need to ask him. TA. Okay. And now we're talking about the happening base. Do we want to try? It looks like this. If we have base, this one attached to O, no, this one attached to H, that one go back, and then we will have something just like this, and then this one attacks there, this one goes back, and this one will be something like that. This one is minus, and if we have HB, that one goes there, this one go back. So we will have something like this. So when we're drawing it, oh, look at that. When we're drawing the Howard's projection, so we label it first. 1, 2, 3, 4, CHROH, OH, HOH, HOH, HH. So we label first. 1, 2, 3, 4, 5, and 6. After we label it, we lie it to the 90 degrees. So CHO, we have H, we have OH, we have HH, and CH, 2OH, and OH, HOH, and OH. Okay, after laying it down, and this one, this is 1, 2, 3, 4, 5, 6. This one folds back. So we have this one folds back. This one C6 pointing up. So for D sugar, for D sugar, 6 point up. So we have (6CHROH) and this is 6, this is 5. Okay, 5, 4, 3, 2, 2, 1. This is O. So 5, 6, 5. This is a OH. This is H, OH, 4, 3, OH, H, RH, OH, E, OH, H, right? This is done. Okay. To be able to quick cyclize a Fisher into Howard position with horizontal it, and then position position C5 to the right of the ring. Always draw H in the ring to the right. Six always up for D sugar. The same can be done for L. Let's practice an L. So CHO. (1, 2, 3, 4, 5, 6) right? And then we have something like this, right? This is O. And 1, 2, 3, 4, 5, 6. I mean, because this is L sugar, 6 will be pointing down. And this will be H. And then so number 4, horizontal. So OH, H horizontal, OH, H horizontal, H, OH. So did I draw it correctly? OH pointing down, O. This one is just OH, O, OH, done. Okay. For the 5th, it's the same thing. This is D sugar pointing up. Okay. The anomeric carbon, the new sterile center formed in the hemiacetal originates from the carbonyl carbon, and this carbon is called hemiacetal original from carbonyl carbon. Only carbon with 2 oxygens, so anomeric. So anomeric carbon. How to remember? How to remember anomeric carbon? Acted as carbonyl. Alpha down, beta up. Alpha away, beta bodies. Anomers. These two stereoisomers, which differ only configuration of anomic carbon, called anomers. Anomers. Diastereomers, epimers. So alpha away, beta bodies. Okay. The destinations is not affected even if the sugar is drawn on a conformational representation. So for glucose, all substituents are equatorial. So chair would be shown, but need to be familiar with them. So how can we get familiar with it though? The destination is not affected, even the sugar is drawn in a conformational representation. Mutarotation, because hemiacetal readily revert back to their carbonyl and alcohol components, anomers interconvert in aqueous solutions. Aqueous. Even at neutral pH, there is sufficient acid present to catalyze the reaction. Thus, when one anomer is dissolved, an equilibrium mixture of both will form over time. This process can be monitored by optical rotation and is called mutarotation. Note that the rotations cannot be predicted but experimentally measured. Rotamutation. How to remember mutarotation? So muta change, rotation, optically. So mutarotation, change in optical rotation. So it's almost 50-50. Formation of glycosides, acetal of sugars. Hemiacetals can react with another alcohol to form glycosides, which are acetals of sugar. The alcohol is an oxygen nucleophile. So these are also called all-glycosides. Could be alcohol from a sugar. So what? Glycosides are named by writing the name of group of side attached to oxygen followed by the name of the carbohydrate but end in "ide" tells we made an acetal. Acetals of sugar. What is acetal? What is an acetal? A carbon with two OR groups. A carbon to two OR groups. A carbon two OR groups. Glycoside. Formation of glycoside. These glycoside linkages are used to join monosaccharides together. The mechanism of hemiacetal to glycoside conversion is an acid-catalyzed SN1, which involves a carbon-cation intermediate. A mixture of alpha and beta glycosides is formed regardless of which enomer of hemiacetal we start. So we have, so we're so hemiacetal to glycoside. Hemiacetal to glycoside. What is a hemiacetal? So hemiacetal would have, so acetal has two OR and hemiacetal only have one OR and one OH. And glycoside, how about glycoside? So glycoside is equal to acetyl sugar, okay? So we're converting from hemiacetal to acetyl sugar, okay? So this is SN1. We start with CH2OH, OH, 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 and then with H plus and CH3OH. We have O attack to H, then we will have OH2. After OH2, because we have 2 protons, this will be very protonated. However, this has electrons. So this get there, this get there, so it will be a leaving group. And then after it left, so we will have this, and this one will be positive, and we have CH3OH, and this can be added from the top or from the bottom. We will have HOCH3, and this one, because it's added to why, how, how about this one? Yay. I don't understand. Okay. Note, glycosides are stable in basic and neutral. They will not convert to their open chain. This is in they will not convert to their open chain form unless either acid or the enzyme is present. Glycosylic linkage are found in drugs and natural compounds. Coniferin is mean glycoside found in sap of conifer trees. The anomeric carbon of acylic hemiacetal can also react with amines to form N-glycoside. This forms in a mechanistically similar way to O-glycoside. N-glycoside are found in nucleosides, which are components of nucleic acid in both attached to the hemiacetal. Oxidation reduction reaction. Since carbohydrates contain carbonyl groups and alcohols, it can undergo redox reactions typical of these function groups. Oxidation to aldonic acid. The aldehyde group of aldose can be oxidized to form carboxylic acid. Sugar with this OH to COOH oxidation are referred to aldonic acid. How to remember aldonic acid. Aldehyde, aldose sugar， 一定是 aldose sugar 吗？ aldose sugar 是有特殊长相的 sugar 吗？ aldose， aldonic sugar. Why I don't see it. What is aldose sugar? Aldehyde becomes acid. Aldehyde, oxidonic. Aldehyde becomes acid. Because hemiacetals are in equilibrium with the open chain form, they are also oxidized if the hemiacetal is derived from aldehyde. Only is selectively oxidized by weak oxidizing agents. Several methods can perform this task without oxidizing other alcohols. Bromine dissolves in water. Bromine water, a relatively gentle technique, molecule B bromine reduced to 2 bromine ions. Metal ions. So we could have Tollens reagent. We could have Benedict reagent. With both bromine and ion reagent, the reagents themselves reduces because the aldehyde group of sugar redox oxidant. These sugars are called reducing sugars. So from aldehyde to carbonyl, from aldehyde to acid, oxidant being reduced from being reduced means red cat. Redox oxidation, red ox. So oxidation lose, but something is being reduced means gain. Okay. Oxidation to aldaric acid. If nitric acid, a strong oxidizing reagent, is used, both aldehyde and primary alcohol are oxidized. We're using this. This is being oxidized, and that one is being oxidized. So both top and bottom. Oh, how to remember aldaric acid. Derek. Double acid reaction in carbohydrates. Double acid, Derek. Acid at both ends, or both acid reaction in carbohydrates. Both acid action in carbohydrates. Derek. However, too weak for secondary alcohols. So it is just primary. Analysis of oxidation product can provide useful structural information on the original sugar. Optically active, optically inactive. Remember, methyl compounds are optically inactive. Oxidation to uronic acid, a simple synthetic method to oxidize only primary alcohols to an acid but leave aldehyde alone. What? Why are those one not? That's not this. However, enzymes can perform this task. Glucuric acid is used by the liver to detoxify toxic substance containing hydroxyl groups. This is done by combining gluconic acid and the substance to form glucuronides, which may then be excreted in urine. So this is enzyme that I don't have. Some drugs such as morphine, THC, and anabolic steroids and excreted as metabolites bound to glucuric acid. Drug testing look for these compounds. Uronic. You oxidize the uronic acid oxidation at the ramp. At the ramp. At the ramp. At the ramp. Oxidation at the ramp. Okay. Reduction. Reduction to alditols. Carboxyl group can be reduced to alcohols by a variety of reducing agents, including catalytic hydrogenation. These sugar alcohols are poorly absorbed and metabolized by the body. Is commonly found in sugar-free candies. If ketones are reduced, a new sterol center may be formed. How about alditols? Aldehyde to alcohol. Isn't the same? Isn't this the same as isn't alditols the same as alcoholic acid? So this is aldehyde 2 alcohol. Reduction of alpha carbon. And this will be mechanisms. And we have learned more. Oh wow, esterification. And we have learned until here. Okay. So this is 42. I got two audios. I got to here. I got until here. 7, 8, 9, 10, and disaccharides. We haven't learned disaccharides that much. Sucrose. We're gonna learn polysaccharides, glycogen, cellulose, catabolism of glucose. Okay, how's glucose digested? And all different kinds of glucose. Oh wow. Pyruvate kinase. Oh my god, these are the things that I did not understand, and now I'm learning it. I guess it's good. Okay, let's go. Never ending study. Never ending study. Getting crazy. I am getting crazy. Crazy. I am getting crazy. These are going together. These are going together. These are going together. And these are going together. And closing this. Oh,